Hello there, welcome to our lessons for this week. We have lesson 64 in Algebra 1, right? I guess it's Algebra 1 here, right? So, and then we'll go to lesson 64, and then we'll go to 65, 66, and 67. Okay, so for 64, I read our topic here, right? But it's domain and inequality review. So for domain here, domain is simply, at least how we talk about them, usually it's our x values, okay? So we'd say that's our x values, okay? We could define it a little bit differently as well, right? So we could say x values, but we could also say another thing, say that it's the potential input values, okay? Because we have functions, we have input values, so potential input values. This will come up later in our discussion in Algebra 1, okay, with input values. Okay, so we're just talking about the range of possibilities in the x direction, right? So if I drew real quick, right, and said, okay, well, I have this graph right here, and this is x, right? If I pick an x value, right, then it'll affect what my y value is over there, okay? And we're not talking about all that necessarily right now, but just know, right, when I'm talking about domain, I'm talking about the values just there in the horizontal. Okay, now let's think about graphing then. So if I go to example 1, we've done this graphing before, so it says to graph x is greater than 2, okay? And then it says do all of the real numbers, right? So we learned about real numbers last week. Okay, so real numbers includes anything, right? It includes fractional numbers, includes ones that have repeating decimals or irrational, right? So if I'm going to graph this, right, always start with the number that's given, right? 2. So I'll just start my graph, I'll put 2 in the middle, and then I'll give it a number on either side. So 1, 3, right? Maybe I'll give it another tick mark on either side, okay? And then since x is greater than 2, that means it's not possible that x is equal to exactly 2, right? So usually how I want to do this, and I'll usually do it right above the line so that it doesn't get mixed in with everything else, right? Then I have an open circle, and then since x is greater than 2, right, that means I'm going this way, and that's it. Okay, and let's quickly go to our next example here. So we have example 2. This one says x is, and then they have this greater than or equal to, then they cross it out, 3, okay? So that, if we're going to read it in words, we say x is not greater than or equal to 3, right? I'm going to say, well, how do you translate that? Well, you think of the exact opposite, right? And say, okay, well, x and 3 are exactly the same, so I can put those there. What's the opposite of having that little, we talk about like an alligator mouth pointing to the left? Well, it points to the right. And what is the opposite of having that line at the bottom that says or equal to? Well, it's simply having it gone, right? So it's not going to be there. So then we write this, x is less than 3. So let me just go ahead and graph that. So we say, okay, 3 is here, and we can put 5 up here, and then 2, 1, right? So this is 1. And they said the domain here is integers. Integers. Now, if you remember for integers, right? Integers were like if I have -2, -1, 0, 1, 2, right? And I can keep going. It's like those numbers, right? As I said, if x is less than 3, right? That means I'm not going to include 3, so I can put an open circle there, right? It doesn't really matter because the next one, the next integer is 2, right? So what I'm going to do here instead is I'm going to put a dot above it, right? And I'll put a dot above 2 because it's possible to have 2. It's not possible to have 2.5. And then the next possible one is 1, so it's possible to have 1. And then I can just go ahead and put an arrow going in that direction. Maybe this is the neatest way of doing this here, but it gets the point across, right? I can point my arrow that way and show that it's integers. Okay. All right. Now that last one that I want to highlight here before we get into solving some of these is example 4. And example 4 simply says that x is less than minus 1. Okay. And then it says that I have positive integers. Okay. So positive integers. So basically, they're talking about having right whole numbers, basically. Okay, and if I think about that, hey, let's think about that for a second. We're like, okay, positive integers, and x is less than minus 1. Well, that is not going to work at all, right? Because if I say it's less than 1, there are no positive integers less than 1s, right? So then for this one, there is, we just say no solution, right? Or we could say there's no graph, okay? But we'll say no solution for here. Or if you want to say another way, right? They just said solution is, right? Then you just say, they were right there, they said the null set. So the solution is, they write it like this. Okay? They cross the whole thing out. Okay, it should make sense, right? X is less than minus 1, positive integers. That does not make sense. All right, now let's talk about solving inequalities, right? So solving rules of solving equations. So say rules of equations apply to inequalities. Trying to write faster here, my pen here. Okay. Okay. So, we don't use an equal sign in inequalities, right? You can notice, right? I'm using this less than, I'm using greater than, right? So those things are different, but pretty much that's the only thing, right? I still want to, right? What's my goal? My goal is to isolate the variable, right? So isolate the variable. So let's go to my example here, and I think you'll see that it's pretty straightforward. I have x minus 3, and it's greater than or equal to minus 5. Okay? If I had an equal sign here, right, just pretend I had an equal sign here, right, and you say, okay, well, if it had an equal sign there, I'm trying to isolate x, right? What am I going to do? Well, I'm going to isolate my x, right? So I'm going to say plus 3 here, right? And if I say plus 3, I better say plus 3 on the other side. Then I have x over here, and then I have greater than or equal to, and then minus 5 plus 3, I end up with minus 2. That's what I have, right? And right here, they actually did tell me my domain, so making sure you pay attention here, they said I have integers. Okay, and so minus 2 is my starting point, so I'm just going to highlight that, and minus 1, or minus 3, minus 4, right? So minus 4 down here, and minus 1, 0. Okay, and 1, okay. X is greater than or equal to minus 2. Let's choose a different color to highlight what this graph's going to look like. Well, I can include minus 2, so I got that. And then my integers, that's my integer, that's my integer, this is my integer, and then I can draw an arrow going in that direction. And that completes it, right? The trick part was just doing this thing right here. Okay, and when you get to the practice, you'll see there's some inequalities there Remember for this one up here, what do we do right away before we did anything? We went ahead and translated this guy over to this, right? And said, hey, this guy is going to look like that. We're going to do the opposite there. So when you get to practice, do that and go through those. And when you're ready, you can go on to lesson 65. Okay, so lesson 65. Okay, so 65, we're gonna talk about adding radicals. Okay, okay, what are radicals? Okay, well, radicals are just like these square root looking things, right, with higher powers. So here we go. So adding radicals, and then we're going to talk about weighted averages also. Adding radicals and weighted average. Okay, weighted average, right? That's like your grades, for example, in class, right? They're some sort of weight. Everything counts for different amounts. Okay, so if I think about these, right? So let's just write something down here, right? I have 4x plus 5x, and that's going to equal what? I think all of you guys know this, right? It's going to equal 9x, right? Because I have x's, I can combine those, right? So this leads us to the rules of radicals, right? So two rules of radicals, right? Combine, right? What did I do here? I only combined the coefficients. Here, let me fix my O there. Combine coefficients. So the coefficients are the numbers that are in front of the variables, right? So combine coefficients. And what did I do here? Did I change the x? No, I didn't, right? So do not change. And this time I'm going to say radicand, okay? And you'll see what I mean when we do this other example here. Radicand. Okay, let's try to keep our example that's above here, which is not an official example, okay? But if I do example 1, I end up with something like this instead. I end up with 4 root 2 plus 5 root 2, okay? And say, okay, how does that look similar to what I just wrote above, right? And say, oh, well, the only difference is that x, instead of x being there, I have root 2, right? Because up here, this is 4 times x, this is 5 times x, and then this is 9 times x, okay? But over here, I have 4 times root 2, 5 times root 2. So when I add it together, then I'll get 9 root 2, okay? Okay, so the rules are exactly the same. Okay, now let's do another example. Let's do example 3, okay? So I guess I could go up here and just state, right? If I have if I have x plus y, I can't combine those, right? That is just simply what it is, right? If I have x plus y, that's my answer, right? Okay, so you'll see that for example 3, right? If I have minus 3 root 2, okay, so I'm going to look for other things that have root 2. I have plus 5 root 3. Okay, so that's different, right? And then, but then it's multiplied, or I mean not multiplied. Then I'm going to subtract 2 root 2. Then I'm going to add 8 root 3, right? I have to look at and see which ones are like, right? And I can underline this if I want to, right? And say, okay, what do we have here? Well, a root 2 is over there, a root 2 is over there. And then, right, pardon all the writing here, but if I have that, then I have root 3 here, and I have root 3 here. So I can combine these, right? Or at least the ones that are like. So let's go back here. look at my root 2's. So I have root 2's. So if I have minus 3 root 2 and I have minus 2 root 2, that means I have minus 5 total, right? So I have minus 5 root 2. Okay? Just like if I had minus 3x and minus 2x. And then for my root 3's, I have 5 of them first right here, right? And then I have 8 later, so that means if I add them together, I get 13 root 3. There you go. That's it. Okay? And I'll just highlight those two. And, well, I guess I could do example 4. Example 4 is pretty straightforward, okay? Because with example 4, I'm told to add together 4 root 3 minus 2 root 2 plus 6 root 5. Say, okay, let's think about this. I have a root 3 in this first one, a root 2 in the second one, and a root 5. So actually, I can't combine any of it. So this is my final answer. Just trying to give you a trick question. You call it a trick question, but it's just a question to test your comprehension. Okay? Alright, so there we go. So it's just like adding these variables. Now let's go to weighted average, right? So if I talk about weighted average, right, like I said, I'm talking about like how your grade is calculated. Weighted average, right? Not all values count the same. So if I want to calculate it, then I can say, well, I have a value, right? So multiply values by weight, right? So we'll say multiply values by their weight, whatever weight they told me they were, right? It's the E here, sorry. And then I'm going to add the products, right? So add with a multiply to, so add products. And then lastly, right, I'm going to go ahead and divide. And when I divide here, I'm going to divide my total. Okay, so I'm dividing my total number here by the number of weights, right? Number of weights. This will be a little more obvious once I pull out an example here. Okay. All right. So now we got our 3 steps there. Let's go ahead and see if we can practice it. So if I have example 5. What did they tell me? They said Jim had scores of 60, 70, 80, and 90. Okay, so he had 60, 70, 80, 90. So if I hear that, right, I can probably go ahead and just do this, right, and say 60, 70, 80, and 90. I can put them in a row like this. Or I guess it's a column, right? So 60, 70, 80, 90. And what is the weighted average of his scores? And the tests were weighted 1, 2, 4, and 6 in that order. Okay, so they're weighted 1, 2, 4, and 6, right? So basically it means that if it's 1, 2, 4, and 6, it means that his score of 90 counted more, right, than his score of 60, right? So then I can say, okay, well now I'm going to, right, was my first step, multiply the values by the weight. Well, I found the values and then I have the weight, so I can say, okay, I'm going to multiply, so I can use a little small x here because I'm multiplying. That means I'll have 60 for this top number, right? I'll have 140 for this second number. For this third number, 80 times 4 means I'll have 320. And for this bottom one, I have 90 times 60, so I have 540. Right? Okay, my second step is to go ahead and add all of my products, right? So I can add all of my products together, right? So then that gives me, let's see here, 1060, okay? For 0, and then I have 6, and I have 10 for that last column. Okay. And then it says divide total by the number of weights. Okay. My weights are these things in this column here, right? Those are my weights. Number of weights. So I have 3 plus 4, 7, and then I have 6. So that means I have 13 weights total, right? Okay, so it's like I have 13 test scores, for example, right? I had 6 scores that were 90, I had 4 that were 80, I had 70 that were, I had 2 that were 70, and I had 1 that was 60. Okay, does that make sense, right? You can kind of see that, right? Now, I want to go ahead and divide then. So I want to do 1060, and you guys have your calculator, right? So 1060, and I can divide it by 13, right? This would be like the average score, and that comes out to be 81.5. Okay, and that's it. Okay. Now, if I have percentages, right? So moving on from this one, right? If I have percents, right? If, right? So let's say if weights are percents, then first, right? We just go ahead and make sure they add to 100, right? Make sure they add to 100%. And the other thing, right, is make sure that they're in decimal form, right? So let's see here. So example 6 is a good one to look at. So we have example 6, and let's go ahead and see what that says. So it says graduate level course, right? And this guy Smith R was taking each of the 3 tests were weighted 20%, and the final paper was weighted 40%, right? So he had 3 tests that were weighted 20%, right? So I have 3 tests weighted 20%. So if they're 20%, right, then that means that in decimal form, that's going to be 0.2, right? Okay, so 20%, and then his other test, his final paper was weighted 40%, right? So his 40% was his final paper. So that's 0.4. But I said he had 3 of these, right? He had 3, and then he has 1 of these. So let's make sure those add up, right? So we say, okay, well, I have 0.2, 0.2, 0.2, and then I have 0.4. If I add those up, right, 2, 2, 2, and 4, that gives me 1 or 100%, right? Okay, so now let's look at the score. So it says scores on 3 tests were 60%, right? So we got a 60%, right? So 60% is like having a 60 on your test, right? And then a 70%, an 80%, and then his final paper was a 60%. Right, so actually, let me go back and say this up here, right? If I was to go ahead and say these scores up here, these scores that he listed up here, they didn't say percentage, but these are percentages, right? So this is like 81.5%, right? Just like all of these were percents right here. I just list them like that as scores, okay? So then I can multiply these out. Right now I have, instead of weights that are whole numbers, right, I have this. And this is how, like, your grades are weighted in class, right? I have these percentages here, okay? So I'm going to go ahead and multiply this out. So I get 12 for this one, I get 14 for this one, I get 16 for this one, and I get 24 for this one, right? And then if I add those up, then I get 66%, right, or 66. And then if I add up the weights, right, then I just have a weight of 1.0, right? So that means that's your whole grade. So 66% is going to be the final grade for this person in his graduate level course. Okay, so Obviously, you can do 66 divided by 1, but it's just going to be the exact same thing, okay? So you don't divide at the end like you would before, but you can divide, right? I just do 66 divided by 1, right? Which would be the exact same thing. All right, that is lesson 65. Go to the practice there and see if you can make it through those and have any questions, okay? All right, and if you made it through that, we'll go to lesson 66. Okay, so we have a thing where we're simplifying radicals. Okay, so you might remember, right, when we said we're talking about radicals, we're talking about these expressions that have this square root symbol over them. Okay, so let's write this out. So 66. Simplifying radicals and roots. Okay, so I want to think about perfect squares. Okay, so this is where perfect squares come back in, right? We talked about this last week, but I want to think perfect squares, right? So perfect squares, what were those again? Right, just try to refresh your brain as I write this down here. Perfect squares are something like square root of 4, right? Square root of 9, square root of 16, and I can keep on going, right? But it's just if I solve these, I end up with a whole number out of them, right? So, for example, 1, right? I have square root of 18, then I want to add the square root of 8, okay? And in the previous lesson that we talked about, this first one, we can't add those together, right? Because they don't have the same radical inside, right? They're not like terms. But what I can do is say, well, I see that if I did the square root of 18, I could break this down into 9 times 2, right? So that is a perfect square right there, and then root 2 is just on its own. Okay, that would become 3 times root 2. Okay, so that one's 3 times root 2. And then say, oh, well, you know what? Square root of 8 has the square root of 4 as a perfect square. So then this one becomes square root of 4 times square root of 2. And you don't have to write all of these out all the time, but I think it's a helpful thing to do it first. Because then you can see how they all work out. Oops, square root of, mess this 2 up here. 2, okay. And then I can write plus 2 root 2, and then you can do what we did in that lesson 64, I think it was, right? And say, okay, now this is 5 root 2. Okay, so that was the goal, just to get into a simplified version like that. Okay, and then let's do example 2 real quick, and then, or example 3 rather. And then we can look at a example that has a really large number. So square root of 27. The square root of 27 looks like it could be familiar, right? But it's a little bit different, right? Because it's not a perfect square. And then we have minus 3 root 18. And then we have minus 6 square root of 45. Okay. Square root of 27. Okay, well this looks interesting, okay, but it's not going to be a whole number. Square root of 25 would be a perfect square. So instead, right, I say, okay, square root of 27 has in it the square root of 9. Has the square root of 9, and then I can say square root of 3. Mess this thing up here. Okay, and that becomes 3 root 3. Okay, so then I have 3 root 3 here. Made my right side kind of small here. Okay, and then I have root 18. Well, what was root 18? Root 18 was just 3 root 2, right? So it's up there. So then I can say, okay, then that's just minus 3. And then I have my parentheses, right? And say, okay, well, root 18, so then it's just 3 root 2. Okay, you see how I did that? I just brought this thing down here. a little bit a little bit at first, right? But you should be able to see that. And then this last one is root 45. Okay, so root 45. Root 45, you say what perfect square is in there? Well, it's actually a 9 as well. So it's root 9, and then it's root 5. And then it just becomes 3 root 5. Okay, and so then you just have minus 6 times 3 root 5. And then simplify from here, right? That 5 looks like an S here. 5, okay. And then I have 3 root 3 again, right? So I have 3 root 3. And then right here, right, this is distribution. So let me get a line here, right? Then I say, okay, well, I can multiply that, right? And then I have minus 9 root 2. Okay, so it's not the same as root 3. And this last one, right, I'm going to multiply like this. Then I'll have minus 18 root 5. Okay, so even though I did a little bit of work here, I didn't actually accomplish like combining or anything, because this root 3 is not the same as root 2, and it's not the same as root 5. So this is my final answer right here. So I don't have to combine anything, none of those combine. So that's my final answer for example 3 there. Okay, now let's think about example 6. So example 6 has this really large number, right? It has 40 million. Okay, so I have 40, and then I have 3 zeros here, and then I have 3 more zeros, right? So that's 40 million. If I want to simplify here, right, then I'd like to just say this, right? And then I just say use square root of 100, right? Use square root of 100 for every 2 zeros, right? Man, I don't know how to write zeros, okay? But I guess it's zeros. I think I better change that. It doesn't look very clear. Zeros. So, I have how many zeros here? I have 1, 2, 3, 4, 5, 6. Right? So that means that I can write this and I can say, okay, this is going to equal, and I would say 3 of these, right? So I can say square root of 100, square root of 100, square root of 100, and then I can say is multiplied by 40, right? That's what's left. And then from there, right, then I say, well, this is 10, and that's 10 times 10, and this is times 10. All right, well, square root of 40, it's actually, I could write it as square root of 4, and then I could write it as square root of 10, right? So if I did 10 times 10 times 10, right, that is going to be 1,000. So then I have 1,000. And then square root of 4 is 2. So then I say, okay, then it's times 2, and then it's times the square root of 10. And so then I have 2,000 times the square root of 10. Alright, so actually it's not too crazy complicated. It's pretty straightforward how you do that, right? You just have to think about what multiplies to the previous answer. Alright, and that finishes up lesson 66. So go to practice there and make sure you can get through those and have any questions. Make sure you have any questions brought up and ask those, okay? Okay, lesson 67. Okay, our last lesson here for today. We're going to talk about elimination. So we have talked a little bit about substitution. We may have even done a little bit of elimination here. But elimination when we're solving equations. Okay. But elimination, okay, I'll just put a requirement here. Okay, it requires X or Y. Okay, so it requires X or Y to have the same coefficient. Oops, have same coefficient with opposite signs. Okay, so opposite signs. So you say, okay, coefficients. Well, a coefficient is the number that's in front of the X or the Y. Okay. Example here would be I have X plus 2Y, and this is just an example here. And I have it equal to 8. And then my other equation, okay, I'm going to just separate it like this, is 5x minus 2y is equal to 4. Okay? Alright, well, what do I have here? So 2y, will have the ugly 2. Okay, that's one thing I have. Let's look at this. So I have coefficient. So I have coefficient in this first one is 1, okay, times x, and then I have plus 2y, and then I have equals 8, and then I have 5 times x, and then I have minus 2 times y. Well, the x's have a coefficient of 1 and 5, so they're not the same coefficient. But then my y's, I have a 2y and I have a minus 2y. So those are the same coefficient basically, they just have different signs. So that means what I can do here, I can do it either way, right? But I can go like this and say, okay, then go ahead and add this one, right? So I can say, okay, then I can write 5x minus 2. I can add the equations together, right? So I'll add the equations together. I get 4. So now I'm going to add them all together. So I'm going to add them together. So that means I'll have 6x. Then my y's disappear, right? They cancel each other out. And then I have 12, right? Which means my x value is 2. Right? If my x value is 2, right, then I have over here, I can go ahead and plug it back in over here, and that means I have 10 minus 2y, and it's equal to 4, right? And then, if I go ahead and solve this part, and say, okay, well, let me do a different color, okay? I'm going to subtract 10 from this side, subtract 10 from this side, and then I end up having minus 2y is equal to minus 6. Right, then I can say, okay, well, I'm going to divide by minus 2, divide by minus 2, right, those negatives will cancel each other out, right, over here too, then cancel, right, then I get y equals 3. And that's it, right, so I have x is 2, y is 3, and we can summarize this. You'll see it summarized different places, but I put the x value first, and I put the y value, so you can say 2, comma 3, and then I put a parenthesis around each one, and then I can box my answer in like this, okay? Nice. Okay, now let's think about another one where I have to multiply both of the equations. That one's set up very nicely for me. If I think about example 3, right, I have 2x minus 3y is 5. And then I have 3x plus 4y is minus 18. Okay, so here I don't have anything that has the same value, right? So really, what I want to call this here, right, is I want to say find a least common coefficient, right? So this is a little bit weird to say because we don't really have terminology for least common coefficient, but anyway, that's what this is doing, right? It's least common and we'll say coefficients. Okay, you say, well, how can I multiply these to get them to be the same sign? Well, there's a couple different ways, right? If I look at my 2x and my 3x, I can go to 6 for both of these and have opposite signs, and that'd work, right? So let's go ahead and do those, right? So if I did that, let's use a different color to do this, then I can multiply this whole equation by 3, right? And then I have 6x, and then I have minus 9y, and then I'd have 15. Now for this one over here, right, I'd only need to multiply by 2. But if I multiplied it by only 2, then I'd have 6x. I wouldn't have the opposite of 6x, which would be minus 6x. So I'm going to multiply it by minus 2. Okay? This minus 2 got a little squished there. But that means I have minus 6x, then I have minus 8y, and it means I have positive 36, right? Okay, now I can add them together, right? So I can, however I want to move them over here, let's move it over here in green, right? And I say, okay, minus 6x minus 8y equals 36. And let's add those together, so that means my x's are gone, and I have minus 17y, and then over here I have 51, okay? So if I divide both sides by minus 17, right, I can just think of dividing by 17, and then the final answer is going to be negative, right? Then I have y, and that goes in 3 times, then y is minus 3, right? So that's one answer. Y is minus 3. And then I can plug it back into one of my final answers, or one of my original equations. So let's go ahead and try it up here in this top one here. So I have 3x, that means I have 3x, okay, and then I have plus 4 times y, so I have 4 times y, so that means I have 4 times minus 3, and this is parentheses, and then I have equals minus 18. And there's no wrong way to do this. I could plug it into the one on the left side here too, okay, but I have this one. Hopefully you can see, right? I just plugged in the minus 3. Now I just have 3x, and then I have minus 12, and then I have minus 18. So I want to move my 12 off this side, so I'll do plus 12 plus 12. Oh, this 12 isn't very much like 12. Okay, and then I'll get 3x is minus 6, which means my x is going to be minus 2, right? Because I divided both sides by 3, right? Or I can show this here. Number 3 divided by 3. And that's my answer there, right? And then I can summarize this again, right? And I can say minus 2, comma, minus 3. And that is my final answer in the proper form, okay? Just like that. So one of those multipliers had to be negative there. To do that, right, the book did it a different way, but I just did it this way because I said, well, it's the x, because I have to multiply by smaller numbers there. But you'll see if you went to example 2, they followed a little bit different step to eliminate their x there. Anyway, let me know if you have any questions. Look for the email with tutor hours, and I'll see you guys next week.